welcome you all. In the last session, I explained you about the concept of searching. Okay, in searching, we discussed one searching technique, that is the binary search technique. So, searching is a process of identifying whether the element is present in the list or not. So, in the binary search, first the array is divided into two parts, left part and right part. At the initial step, it will compare the middle element. So, whether the middle element is the searching element. If in case if it is searching element, then it will terminate from the searching. Otherwise, it will search right part or left part of the array. If in case if our searching element is greater than the mid element, it will check right part of the array. Otherwise, it will check left part of the array. Okay, the process will be repeat until the searching element is found or the condition is not satisfied. The condition is low less than or equal to I. If this condition is not satisfied, then it will terminate from the searching process. Okay. In this session, we are going to discuss the one more topic is the sorting technique. Okay. Sorting is the process of arranging the elements in the particular order. Okay. Sorting is very important for the searching process. Okay. If in case if you order the elements in the particular order or particular arrangement, then it is very easy for us to check the element. If in case if the elements are not in the order, to identify the particular item in the unordered item, then it's very difficult and time consumption. Example, you have a telephone numbers. The telephone numbers are not in the order, then it is very difficult for us to check. We need to check each and every element to identify whether the number is present or not. So, if in case if you order the elements in the particular order, either it may be in the ascending order or descending order, then it's very easy for us to check the item. Example, telephone directory. So, in telephone directory, the elements are in the alphabetical order. So, telephone numbers in the alphabetical order. If you want to fetch the telephone number of the particular person, example, the name is Rama. So, instead of searching from starting letter to last letter, you directly go to that name Rama and search. So, instead of searching entire dictionary, entire telephone directory, we can easily check the alphabetical order R. Similarly, dictionary. So, in the dictionary also, the elements are words and the meanings are stored in the alphabetical order. So, there it is very easy for us to identify the particular word and the meaning. So, arrangement of elements is very important for many process. So, especially for the searching process. So, if the elements in the order, the searching process will be optimized. Okay, there are many techniques for arranging the elements. One is the bubble sort, selection sort, insertion sort, reduction sort, merge sort, heap sort. Okay, like that there are many sorting techniques. So, in your syllabus, there are mainly two techniques. One technique is the bubble sort technique and other one is the selection sort techniques. So, sorting techniques are classified into two types, two categories. One is in place sorting and not in place sorting. So, in place sorting means the elements will be arranged in the same array itself. Array elements will be arranged in the same array itself. Not in place order, the elements will be ordered by using a temporary array or another temporary array location or the other variables. Okay, let us consider one example. Okay, now you consider this array. Here in this array, it contains only four elements, 7, 5, 17, 1. So, in the in place sorting, first the elements will be compared. Now, 7 is greater than 5, then elements will be exchanged. So, 7, next 17 and 7 will be verified, then it will exchange, then 17, 1 will be verified, then 17, 1 exchange. So, the elements are arranged in the same array itself. So, this in place sorting. Okay, now you consider one more example. Okay, now we consider this array. There are two arrays. This is A and B. Okay, in this 5, 15, 17, 25 is arranged. 6, 21, 24 and 27 is arranged. Now we need to merge and sort these elements. So when we sorting the element, we need another temporary array. Okay, that is the resultant array we can consider as C. So first it will compare 5 and 6, then 5, next 15 will be 6 compare, next 15, 21 will be compare, next 17, 21, next 25, 21, next 25, 24, next 25, 27, next 27. So here one more array is required for the arrangement. So in the in-place sorting, the elements will be arranged in the same array itself, but in the not in-place sorting, we require one more array, one more location for arranging the elements. So this is example of not in-place sorting. This sorting is called merge sort technique. Merge sort technique. Okay, now in this session we are going to discuss one technique is called bubble sort technique. So bubble sort technique is the simplest technique for arranging the elements. So the arrangements are done in two ways, two orders. Either it may be in the ascending order or descending order. So if it is a number or integer number or floating point number, we can arrange the numbers in ascending order or descending order based on the value. Similarly, we can also arrange the characters in the alphabetical order, and even strings can also be sorted in the alphabetical order. So A to Z or Z to A to Z or Z to A. So in the bubble sort technique, the arrangement will be performed either in the ascending order or the descending order. So the bubble sort technique is very simple technique for arranging the element. So first you start comparing the first element with the second element. So if first element is greater than the second element, then the elements will be exchanged. Next, second element and third element will compare. So based on the value, the value will be swapped or exchanged. If in case first number is greater than second number, the value will be exchanged. Then second number will be compared with third number. So if in case second number is greater than third number, once again the exchanging will be performed. So like that, the comparison of every element will be performed. Then after comparing n elements, highest element will be moved to the last. Okay. Then in the first iteration, first largest element moved to the end of the array. In the second iteration, second largest element moved to the next largest element. So like that, the process will be iterate until n into n minus 1 time, n into n minus 1 time. Okay. Now consider one example of array for bubble sort technique. Okay. Now we'll consider the array of size. I will consider the array of size 5. Okay. Now let's consider the array elements. 17, 5, 21, 6 and 2. So in the first iteration, it will compare the first element with the second element. So here the comparison will be performed. That is, if A of I greater than A of I plus 1. A of I plus 1. So either you can consider I as an index or J as an index. So first it will compare. Okay, in the first iteration, here the value is 17 and 5. 17 and 5. Now you, after comparing this, 17 is greater than 5. 17 is greater than 5. Now we need to exchange this value. Now we need to exchange this value. So after comparing the first element and the second element, after comparing the first element, second element, the resultant element will be 5, 17, 21, 6 and 2. Okay, this first iteration. First iteration. Next, in the second iteration, it will compare the next element. Next element. The next element is 17 and 21. 17 and 21. Okay, now it will compare 17 and 21. 17 is less than 21, then no need of exchanging the value, then the resultant value will be 5, 17, 21, 6 and 2. Okay, in the next iteration, in the next iteration, 21 and 6 will be compared. 21, 6 will be compared. So 5, 17. Here 21 is greater than 6, then the value will be exchanged, then 6, 21 and 2. 6 will be exchanged, so 6, 21 and 2. Similarly, in the next iteration, 21 and 2 will be compared. 21 and 2 will be compared, so this becomes 5, 17, 6 and 2, then 21. Okay, this is the first fast. So in the first fast is pass 1. So in the first pass, the first largest element is moved to the end of the array. Now this array is not in the sorted order. Array is not in the sorted order. So this iteration 3, iteration 4. Okay. Now total elements is 5. Total elements is 5. So it will compare 4 comparison. So it perform 4 comparison. Okay. Next, the process will be iterate again. The process will be iterate again. So 5, 17, 5 and 17. So 5 is smallest than 17. Then no need of exchanging the value. This value will be 5, 17, 6, 2 and 21. Next, in the next iteration, so in the next iteration, 5, 17 and 6. Okay, here in the next iteration, 17 and 6 will be compared. 17, 6 will be compared. So 17 is greater than 6, then the value will be exchanged. So this becomes 6, 17, 2 and 21. Okay, this is iteration 1. Next, the 17 and 2 will be compared. So this 5, 6. So here 17 is greater than 2, the value will be exchanged. So 2, 17 and 21. So here this is pass 2. Pass 2. Here this iteration 2. In the previous step, it performs 4 comparison, but in here comparison 1, 2, 3, only 3 comparisons. So compared to previous pass, the here number of comparison is decreased. So next, here 21 is already sorted, then no need of comparing 17 and 21. So in the next step, it will compare. In the next step, it will compare 5 and 6. So 5 is already in the sorted order. So the value will be 5, 6, 2, 17 and 21. Okay. In the next step, it will compare 6 and 2. So 6 is greater than 2. The value will be exchanged 6, 17 and 21. So 17 and 21 is already in the sorted order. So there is no need of further comparison. So here 1 and 2 comparison. So in the first pass 4 comparison, second pass 3 comparison, third pass only 2 comparison. In the last pass it will compare only one element, that is 5 and 2. So 5 is greater than 2, the value will be 2, 5, 6, 17 and 21. So here one comparison. This is pass 2, this is pass 3 and pass 4. Okay. In the last pass we get array in the sorted order. So first it will compare 17 and 5. Here 17 is greater than 5, the value will be exchanged. Next 17, 21 will be compared. So here 17 is less than 21, no need of exchanging. Then next 21 and 6 will be compared. Here 6 is smaller than 21, 21 is greater than 6, then value will be exchanged. Then here the value is 5, 17, 6, 21, 2. In the next iteration 21 and 2 will be compared. So 21 is greater than 2, then the value will be exchanged. So the resultant array is 5, 17, 6, 2 and 21. So in the past one, the first largest element is moved to the end of the array. Again next pass 5 and 17 will be compared. So 5 is smaller than 17, no need of exchanging the value. So 5, 17. Next 17, 6 will be compared. 17 is greater than 6, then the value will be exchanged. 5, 6, 17, 2, 21. The next iteration 17 and 2 will be compared. So 17 is greater than 2, then the value is exchanged. So 5, 6, 2, 17 and 21. So 21 is already in the sorted order, then no need of comparing 17 and 21. Okay. In the next iteration 5, 6 will be compared. So 5 is smaller than 6, no need of exchanging the value. So 5 and 6, 2, 17, 21. Next iteration 6 and 2 will be compared. So 6 is greater than 2, the value is exchanged. So that is 5, 2, 6, 17, 21. 17, 21 is already in the sorted order, then no need of comparing the next element. So in the last iteration 5 and 2 will be compared. So 5 is greater than 2, then the value is exchanged. 2, 5, 6, 17, 21. So in the last pass only one comparison. So in the bubble chart, every iteration largest element is moved to end of the array. So first largest element, second iteration second largest element, third largest element, fourth largest element. So like a water bubbles, so highest size bubble will move to the top. Okay, that is the concept of bubble chart technique. So it's very simple technique, in the sorting. In this technique, the elements will be compared based on the element value, the value will be exchanged. Okay, that is about the bubble chart example. Okay, now consider the algorithm for the bubble chart technique. So in the bubble chart algorithm, just we have seen, we need to perform number of passes and number of iterations. So in order to perform number of passes and iteration, we need to use the nested for loop. So for bubble chart algorithm, we need to provide two input. One input is the size of the array, another input is the elements of the array. One is size of the array and elements of the array. So in order to exchange the elements, we need to do comparison. After comparing, we need to perform the swapping of elements. So for bubble chart technique, there are two inputs. One is size of the array, another is the elements of the array. Okay, now consider the algorithm. The first step is step 1, start. Step 2, rate the size of array. That is read n. Okay. Next, step 3. After reading the size, we need to read array elements. So read array elements. So read n elements. n elements. So we have read n. So we need to read n elements. So after reading the elements, step 4, we need to perform bubble chart. So repeat for I is equal to 1 to n minus 1. Okay. Next repeat for j is equal to 0 to j less than n minus I minus 1, because we need to compare. First time we need to compare n minus 1 element, next n minus 3 elements, n minus 4 3 elements, n minus 4 elements, n minus 5 elements. So here in the every iteration it reduces number of comparisons. So next is if a of j greater than a of j plus 1. So first I'll compare the first element with the second element. So if in this case, if the value of the first element is greater than the second element, then we need to perform swap of a of j and a of j plus 1. Okay, this process will be iterated. And if end for and one more end for. Okay, after performing sorting up algorithm, sorting process, next is step 5 display print sorted array. So after displaying the array element, the last step is end. Step 6 is end of the process. So first we need to read the size of the array. So this is the limit of the array. Then we need to read n elements. After reading the n elements, we need to perform the bubble sort process. So by comparing the elements, so first element with second element with third element with fourth element with fifth element. So we need to compare the elements. So in order to compare the element by element, we need a nested for loop. So here one loop is outer for loop, this for number of iterations and j for number of comparisons. So for loop is for number of iterations and j for number of comparisons. So first here we compare the elements. So for I is equal to 1 to n minus 1, for j is equal to 0 to n minus I minus 1. So after that we compare a of j greater than a of j plus 1. So here a initial value j is equal to 0. So a of 0 greater than a of 0 plus 1 means a of 0 plus 1 is next element. So that will be compared. If a of 0 is greater than a of j plus 1, the value will be exchanged. So next, in the next iteration, j value will be increment. So j will be pointing to 1. Next, a of 1 greater than a of 1 plus 1. So next element. So first, second element and the third element. If in case second element is greater than the third element, the value will be exchanged. Next, if in case if the second element is smaller than the third element, next third element is compared with the fourth element. So next iteration, a of 2 is greater than a of 2 plus 1 means a of 2 and a of 3. So third element and the fourth element. So here if in case the third element is greater than the fourth element, then the value will be exchanged. So this process will be iterated until this condition satisfied, that is n minus I minus 1 is satisfied. Okay. If this condition is not satisfied, it will terminate and it go back to the for loop again. Then this process will be iterated, this condition satisfied. So n less than I. So if I value is greater than n minus 1, then the loop will be terminate. Okay, the bubble sort technique will be terminate. Okay, after that it will display the sorted elements. So print step 5, display, print the sorted array, and the last step is the end of the algorithm. Okay, last step is the end of the algorithm. Okay, this is algorithm for bubble sort technique. Okay, now let's consider the program for performing bubble sort technique or arranging of elements using bubble sort technique. Okay, the purpose of the program is to program to arrange the elements in the order. Okay, either it may be in the ascending order or descending order. Okay, first I include stdio dot h void main. So here I already mentioned there are two inputs. One is int size of the array, that is n. Here I will consider array elements, the input array element, that is array A of size 20. Then one index is I outer loop. Then j is one more index. Then one variable is required to exchange a value, that is temp. So I will consider the variable is temp. Okay, next we need to read the size of the array. Printf enter the size of the array. First we need to read size of the array. Double quote scanf %d address of n. So first we need to read the size of the array. After reading the size of array, we need to enter the array elements. Printf enter the array elements. So here we need to read n elements. So for I is equal to 0, I less than n, I plus plus. So scanf %d close address of a of I. So here we read n elements, then the n elements will be stored in the variable a of I. So array variable. After that I will print the entered array. Printf entered array. So before arranging the elements, so entered array as follows. For I is equal to 0, I less than n, I plus plus. So printf %d slash n double quote close a of I. Okay, this for displaying the array elements. Next is the important step, sorting. So in the algorithm I have written two for loops. So for I is equal to 0, I less than n minus 1, I plus plus. So it is outer for loop. Next for j is equal to, so for loop I will set for loop as 1. For j is equal to 0, j less than n minus I minus 1, then j plus plus. So here if a of j greater than a of j plus 1. So first I will compare first element with the second element. If this condition is true, then here we exchange temp is equal to A of j is equal to A of j plus 1, then A of j plus 1 is equal to temp. A of j is equal to temp. Okay, this is the code for arranging the elements. Next, after that, I will print the value printf sorted array for I is equal to 0, I less than n, I plus plus. So printf %d / n a of I. So this is end of program. Okay. Here first I will define the variables n. N is for the size of the array, and A is the input array elements, I is the index value, j is also index value, and temp is the temporary variable for exchange. So here I am using the temporary variable for exchange. Next, I will read the size of the array. After reading the size of the array, I will read the array elements. Next, I will print the array elements. After that, I perform the arrangement of elements. Okay, now you consider one simple example. Here I will consider n is equal to 4. Okay, n is equal to 4. Okay, here this is my input array 21, 7, 2 and 6, 2 and 6. So after entering the value, here I is equal to 1, I less than n minus 1, I plus plus. So here initially I will set I is equal to 1 and j is equal to 0. J is equal to 0. Now you consider j is equal to 0, j less than n minus I minus 1. So what is the value of n? N value is 4, I value is 1. 4 minus 1 minus 1. Okay. Next, here condition will be true. Next it will compare A of j greater than A of j plus 1. So you see A of j is 21, A of j plus 1 is 7. So 21 greater than 7. Now condition is true, then condition is true, it will exchange this value 7 and 21. So here I am using one variable temp. Temp is equal to A of j. What is the value of A of j? A of j is 21 and A of j is equal to A of j plus 1. So A of j is equal to, okay, now temp 21 is assigned to the variable temp. After that, A of j is equal to A of j plus 1. A of j is equal to A of j plus 1. A of j plus 1 is this. This will be copied to here 7. Next, A of j plus 1 is equal to temp. Now 21 will be copied. 21 will be copied to the next location. Next, the loop will be iterate. Next, it will compare. Next, it will compare 21 and 2. So 21 is greater than 2, then the value will be exchanged. So this is 21, 2. Next, 21 and 6 will be compared. Here 21 is greater than 6, the value will be exchanged. This becomes 6 and 21. Okay, this process will be iterate till the condition is satisfied. Once this condition is not satisfied, then it will terminate from the loop. After terminating, it will display the array value for I is equal to 0, I less than n, I plus plus, printf %d / n A of. Okay, this will display the array elements. So the advantage of this technique is very simple to implement, but in this technique it will take more number of comparison because we need to iterate this loop n into n minus 1 times. So we need to iterate this loop into n minus 1 time. Okay, this the advantage and disadvantage of the bubble shot technique. So advantage is it's simple to understand, simple to implement. The disadvantage is it will take more time. It will take more time to arrange the elements. So if the array is a small array, it is efficient. If you are arranging the elements of larger size, then this technique will be inefficient. So it takes more time. So the time complexity of this is big O of n square, big O of n square, or big O of n into n minus 1. Okay. Now this is about the bubble chart technique. Okay. In the next session, I will explain you about the one more sorting technique, that is selection chart technique. Thank you. Just now I explained the concept of bubble chart technique. So bubble chart is a technique for arranging the elements in either ascending order or descending order. Okay. In the bubble chart, the element will be compared. So first element will compare with second element compare with third element. Like that, the comparison exchanging operation will be performed. So here this is a program for performing the arrangement of elements using bubble chart technique. So for this program, there are two inputs. One is the size of the array. Okay, the size will be stored in the variable n, then the input array. So here line number 10 to 13 is the code for getting input from the keyboard. Next, after that, the line number 14 to 18 is displaying the array elements. Okay, next, okay, this line number 19 to 30 is the code for performing the arrangement of the elements. So first for loop is the outer for loop. Outer for loop is set to I is equal to 1 to n minus 1. Then for j is equal to 0 to n minus I minus 1. So a of j greater than a of j plus 1. So first element is the index 0. Second element is j plus 1, that is first element and the second element. So first element is greater than the second element. If this condition is true, then the value of a of j and a of j plus 1 will be exchanged. First, a of j is copied to temp. Later, a of j will be assigned by a of j plus 1. Then a of j plus 1 is assigned with temp. So temp contains the value of a of j. So like that, the element will be compared based on the comparison result. If the value of a of j is greater than a of j plus 1, then the value of a of j and a of j plus 1 will exchange. So this is the part of the code for swapping of the elements a of j and a of j plus 1. After performing this operation, bubble chart operation, here I am displaying the elements. Okay, sorted array elements are as follows. Okay, for I is equal to 0, I less than n, I plus plus, printf percentage d slash n a of I. Okay, now here I will give 5 elements. The elements are 56, 23, 7, 67, then 2. Okay, this is my input. I can see here the entered array is 56, 23, 7, 67 and 2. After performing sorting, the output is 2, 7, 23, 56 and 67. Okay, this is the output of bubble chart algorithm. So for this program, there are two inputs. One is the size of the array and input array. The output is the sorted array. Okay, here this is the sorted array output 2, 7, 23, 56 and 67. Okay, this is about the bubble chart program.